are numerous challenges that may arise from achieving this goal. Things are talking and generating massive amounts of data at Siemens.
By James Gosling in 1990 at Sun Microsystems. One of its created in 1979 by Bjorn Stroustrup at AT&T Bell Labs.
Lightning speed, and it feels like...
Are you wasting hours chasing the latest tech trends, obsessing over 100% test coverage, or fearing AI will steal your job? What if I told you these are just myths holding you back? In this video, we'll bust 7 common programming myths that secretly waste your time and reveal what actually matters for your success as a developer. Number 7. You need to use the latest technology to stay relevant. The belief that mastering the latest technology is essential for every developer is widespread, but it's often misleading. While new frameworks and languages appear exciting, most of the world's critical systems rely on what some call dinosaur technologies. For example, WordPress and PHP still power a significant portion of the web, Java dominates enterprise applications, and SQL remains the backbone of countless databases. Even C++ continues to run much of the world's low-level infrastructure. These technologies have stood the test of time because they are robust, well-supported, and deeply integrated into existing systems. Chasing every new tool or language can actually distract you from building deep expertise. Many companies value developers who can maintain and extend legacy systems over those who only know the latest trends. The fear of missing out on new tech often leads to a shallow understanding of many tools, rather than mastery of a few. End users rarely care about the stack behind an application. They care about reliability and functionality. Additionally, many organizations are slow to adopt new technologies due to the risks and costs involved. CTOs and managers often prioritize stability and proven solutions. By focusing on fundamentals and gaining real-world experience with established technologies, you become more valuable in the job market. Number 6. Adopting new frameworks. Early gives you an edge. Jumping on the bandwagon of new frameworks as soon as they're released can seem like a smart move, but it's often riskier than it appears. Early adoption exposes developers and organizations to a host of uncertainties. New frameworks may lack comprehensive documentation, have undiscovered bugs, or even face uncertain futures if their creators pivot or shut down. For example, when a proprietary database like Fauna shut down, early adopters were left scrambling to migrate their data and rewrite applications. Frameworks in their infancy often undergo rapid breaking changes. This can lead to significant rework and maintenance headaches as APIs evolve. Companies that prioritize stability may hesitate to adopt tools that haven't proven themselves over time. Relying on unproven technology can also create hiring challenges, as fewer developers are familiar with the stack. Instead of gaining a competitive edge, early adopters may find themselves spending more time troubleshooting and less time delivering value to users. The promise of increased productivity or performance is often offset by the costs of migration, retraining, and dealing with unexpected issues. Established frameworks, while less flashy, offer a wealth of community knowledge, third-party integrations, and long-term support. The real advantage comes from knowing when to adopt new technology, waiting until it's stable, well-supported, and aligned with your project's needs. Selective adoption, rather than blind enthusiasm, is the key to leveraging innovation without unnecessary risk. Focus on delivering solutions, not just experimenting with the latest tools. Number 5. There's only one true programming paradigm. The idea that a single programming paradigm, such as object-oriented, functional, or procedural, is the right way to write software is a limiting myth. Software development is a creative field, and different problems often require different approaches. Languages like JavaScript are explicitly designed to support multiple paradigms, allowing developers to choose the best tool for the job. Rigid adherence to one paradigm can lead to inflexible code and missed opportunities for better solutions. For instance, object-oriented programming, also known as OOP, excels at modeling complex systems with interacting entities, while functional programming, also known as FP, shines in scenarios requiring predictable, side-effect-free computations. By understanding the strengths and weaknesses of each paradigm, developers can mix and match techniques to suit their needs. Hold on a second, do you believe there's only one right way to write code, or do you mix different programming styles? Share your thoughts with us below. Communities sometimes form around paradigms, creating a sense of exclusivity and purity. This can discourage experimentation and learning. In reality, most successful projects borrow ideas from multiple paradigms. For example, a web application might use OOP for its domain model and FP for data transformations. The best developers are those who are pragmatic, not dogmatic. Embracing flexibility leads to more maintainable and efficient code. It also fosters a deeper understanding of software design, enabling you to tackle a wider variety of challenges. Instead of seeking the one true way, focus on building a diverse toolkit and learning to apply the right approach in the right context. Number 4. Clean code principles should always be followed rigidly. Clean code principles like meaningful naming, small functions, and consistent formatting are undeniably helpful, but applying them without flexibility can backfire. The software development classic, Clean Code by Robert C. Martin has inspired many to write better code, but strict adherence to every rule can lead to diminishing returns. For example, the DRI Don't Repeat Yourself principle encourages developers to avoid code duplication. While this often improves maintainability, overzealous application can result in convoluted abstractions and unnecessary complexity. Sometimes duplicating code is the simplest and clearest solution, especially in the early stages of a project. Only when repetition becomes a genuine pain point does it make sense to refactor. Similarly, striving for perfection in naming or structure can lead to paralysis by analysis, spending excessive time refactoring instead of delivering features. Endless layers of wrappers, interfaces, and indirection may satisfy abstract principles, but can make code harder to understand and maintain. Clean code should be a guide, not a set of unbreakable laws. The ultimate goal is to create software that is easy to read, modify, and extend. Context matters. What works for a large team on a complex system may be overkill for a solo developer or a small project. Pragmatism should always trump dogmatism. Use clean code principles as tools to improve your workflow, not as rigid commandments that stifle progress and creativity. Number 03. 100% test coverage means your code is safe. 100% test coverage is often seen as the gold standard for software quality, but this number can be deceptive. Achieving full coverage simply means every line of code is executed by some test, not that every possible bug is caught. Developers may end up writing superficial or redundant tests just to satisfy the metric, rather than focusing on meaningful scenarios that actually catch real-world issues. This can create a dangerous illusion of safety, leading teams to overlook edge cases or integration problems that tests don't address. Managers and non-technical stakeholders are sometimes swayed by high coverage percentages, believing they guarantee robust code. In reality, a suite filled with trivial tests, such as those that merely check if a function returns without error, adds little value. Worse, it can slow down continuous integration pipelines, increasing build times and costs without improving reliability. Effective testing should prioritize quality over quantity. It's more important to write targeted tests that validate critical paths, handle unexpected inputs, and verify integration points. Blindly pursuing 100% coverage can distract from exploratory testing, code reviews, and other practices that uncover subtle defects. Instead of obsessing over the coverage number, focus on creating a resilient test suite that evolves with your application. Remember, the ultimate goal is to prevent costly bugs in production, not to achieve a perfect score on a dashboard. Prioritizing meaningful tests ensures your codebase is truly protected, rather than just appearing safe on paper. Number 2, you must always optimize for performance and scalability. The drive to optimize for performance and scalability from the outset is a common trap for developers. While it's tempting to architect systems as if they'll serve millions of users, the reality is that most projects never reach that scale. premature optimization can lead to unnecessary complexity, wasted effort, and even slower delivery of features that actually matter to users. Focusing on micro-optimizations, such as shaving milliseconds off a function or building elaborate distributed systems, often distracts from ensuring your application is correct and reliable. Many legendary software engineers, including Donald Knuth, have warned that premature optimization is the root of all evil. The best approach is to build a solid, maintainable foundation first, then profile and optimize only when real-world usage reveals bottlenecks. Before we move on, what's your biggest myth about programming that you used to believe? Let me know your thoughts in the comments. Cloud infrastructure is another area where over-optimization can waste time and resources. Setting up intricate microservices, global sharding, or edge caching may sound impressive, but it's rarely justified for a small user base. Simple solutions like a single virtual server can handle the needs of most early-stage projects far more efficiently. True performance tuning should be driven by data. Monitor your application in production, gather metrics, and address issues as they arise. This ensures your efforts are targeted and effective, rather than speculative. By resisting the urge to over-engineer, you'll deliver value faster and avoid the pitfalls of unnecessary complexity. Focus on correctness and user experience first. Optimize only when the evidence demands it. Number 1. AI will replace all programmers soon. The notion that AI will soon replace all programmers is a persistent myth fueled by rapid advances in machine learning and code generation tools. While AI-powered assistants like Copilot or ChatGPT can boost productivity, they are far from making human developers obsolete. These tools excel at automating repetitive tasks, generating boilerplate code, and offering suggestions, but they still struggle with context, nuanced problem-solving, and understanding business requirements. AI-generated code often lacks the architectural insight and domain-specific knowledge necessary for robust, maintainable software. Developers who rely too heavily on AI may find themselves approving verbose or inefficient solutions without fully understanding the underlying logic. This can lead to technical debt and hidden bugs that surface later in production. Moreover, creative problem-solving, critical thinking, and effective communication with stakeholders remain uniquely human strengths. AI can assist with coding, but it cannot replace the need for clear requirements, thoughtful system design, or collaboration within a team. The most successful developers leverage AI as a tool, not a crutch, using it to enhance their productivity while maintaining a strong foundation in computer science and software engineering principles. Rather than fearing replacement, programmers should focus on building adaptable skills and a deep understanding of their craft. Staying curious, learning new concepts, and developing critical thinking will ensure long-term relevance in a world where AI is just another powerful tool in the developer's toolkit. Thanks for watching. If you found these programming myths eye-opening, hit like and subscribe for more practical tips. Remember, focus on what truly matters and stop wasting time on distractions. Share your biggest programming myth in the comments. I'd love to hear your story. See you in the next video.